Thank you for joining us today. The following is a video presentation that explores the use of geographic information systems and how they are integrated with mobile application technology. We will touch on the scope of this term and its use before the advent of mobile devices. We will then move into not only the technology behind modern GIS systems, but also how mobile devices communicate with these systems to pinpoint their location. Specific apps that utilize location services will be described as well as security and privacy concerns for the user. This presentation was developed by Jeff Barberio, Shane Metcalf, and Kyle Fabatz for CIS 665. A geographic information system is defined as a system designed to capture, store, manipulate, analyze, manage, and present all types of spatial or geographical data. The origins of GIS can loosely be tied to the digitization of geographic data in the 1960s. This transformation of geographic information from hand-drawn images to sets of data in the form of digital coordinates has given us the ability to perform meaningful analysis in addition to simply representing where objects are located. Now that we have a basic understanding about what GIS is, let's explore two concepts that provide the foundation for GIS. The first is data representation. There are two main ways in which data is represented in GIS. Vector representations utilize X and Y coordinates for latitude and longitude, as well as a Z coordinate to depict elevation. Raster images are similar to the pixels in your computer or television screen. Here, data is represented in the form of a grid of squares with different colors and shades in each square. Point clouds are an emerging technology that add RGB values to vector coordinates in order to assign color. The second is data capture. Before data can be entered into a GIS to be analyzed, it must be gathered from a source. There are a variety of methods for capturing data, so we will just touch on a few of the most common. One way that data is captured is by deriving it from a pre-existing image. Digitizing is a process of taking a previously created map and deriving vector coordinates to it. Scanning is an analogous process used to create a raster image from the pre-existing data. Survey instruments provide another source for GIS data that can be directly entered into a GIS using coordinate geometry. The most predominant source for GIS data, however, comes in the form of remotely sensed data. For remotely sensed data capture, a platform, usually an aircraft or satellite, is equipped with a sensor that gathers data through a camera, digital scanner, or a LiDAR detector, the visible light counterpart to radar. Location-based services is the integration of mobile communication technologies based on mobile networks with location positioning systems, internet, and GIS to provide services with additional value beyond what any one of these technologies can provide on their own. These services include routing, mapping, and searching by physical location or address. Creating these services requires being able to collect, convert, manage, analyze, and present geographic data and make it available to anyone at any time on nearly any platform. While many different systems must come together for location-based services to work, there are four primary components. These components are the GIS architecture, the mobile device, the communication network, and the location positioning system. Typically, modern mobile location-based services are delivered through a software as a service, or SaaS, delivery model. This means that most of the software, data processing, data storage, hardware, maintenance, etc., are hosted by a provider on the SaaS provider's network infrastructure through the internet to a mobile device. This kind of architecture, commonly known as client application server architecture, leverages a location-aware mobile client using a combination of GPS satellites and network-assisted positioning technology. When a mobile client uses its application software to make a request for location-aware services, it sends that request, along with packaged location information provided by the positioning system, to a hosted web server and then to a database server. These servers use a combination of standard web technology, such as HTML, XML, JavaScript, and specialized GIS spatial processing applications, to present a user interface to the user and validate user-provided information. This information is passed to a spatially aware database on a separate server. Any requested data processing is done here, and finally it is passed back to the web server and the mobile client application. The data processing can also be done with a range of standard server-side languages, commonly SQL when querying the database, and ASP for user-provided data processing. This interaction can take place within a wide range of commercial and open source spatial software. A commonly used commercially available GIS software suite is ArcGIS Server, provided by ESRI. Now that we've covered the GIS technology in and of itself, let's discuss how mobile devices and applications integrate with this technology. Essentially, mobile devices that are equipped with a global positioning satellite, or GPS, receiver function as a two-way radio that communicates between itself and a network of frequency transmitters. These transmitters can consist of wireless access points, cell phone towers, and GPS satellites. As mobile devices move in and out of these transmitter networks, they will, in normal circumstances, utilize each accordingly to pinpoint their location. When a mobile device is connected to a wireless network, the media access control, or MAC, address of the device will register as being within the nearest wireless access point, or WAPS, range. Proximity to the closest WAP will create a constantly changing latitude and longitude entry as IPv4 or IPv6 signal strength relative to the WAP ebbs and flows. The WAP itself is transmitting its physical location as well to a location database housed by the Internet service provider. Outside of wireless network connectivity, the mobile device will take advantage of the carrier or service provider's location service. Here, cell phone towers or signal repeaters function as large-scale access points. As the location or cell of the mobile device moves in and out of tower range, specific towers receive the X, Y, and Z coordinates of the associated MAC address and transmit this data to carrier databases over respective data networks such as 3G, 4G, LTE, or Verizon's proprietary XLTE. The ability to pinpoint physical location is further assisted by GPS, the U.S. government's network of now 27 globally positioned satellites strategically placed around the entire world in their own constellation, approximately 12,550 miles above the Earth. Each satellite circles the Earth approximately twice a day. At any given time, a location will be within the view of at least 4 GPS satellites. Through the mathematics of triangulation, latitude, longitude, and elevation are determined by the intersection of each satellite's transmission radius. This type of location service is especially beneficial when a mobile device is outside of normal wireless or carrier coverage range. Virtually hundreds of mobile applications have been developed over time with the intent to provide services to the user utilizing location services technologies. These can be categorized into two primary types of apps: directional apps and retail apps. Google Maps, Apple Maps, Bing Maps, and VZ Navigator, developed by Verizon, all employ location services to not only pinpoint the physical location of the MAC address of the device, but recommend the quickest means to reach a desired destination. Through simple mathematics, the most direct path between these two coordinates is queried and returned within seconds to provide the user ample options, albeit driving, walking, biking, public transportation, etc., on how to arrive at their destination and also the associated time it will take to travel there. The potential to extend marketability and usefulness for each app is seemingly endless, with some incorporating the ability to reference public transportation schedules, traffic, and weather conditions. Runkeeper, Strava, Edmondo, and Map My Ride are only a few examples of apps that provide the user map visualizations of the running, cycling, jogging, or driving route they have just completed. These routes are tracked by the latitude and longitude changes that the MAC address registers with location services. The GPS receiver can interact with the odometer in the mobile device to track speed at any given location. The consumer industry also capitalizes on location services technology. In the mood for McDonald's? Download the McDonald's app and find the location nearest you. What about renting a movie? The Redbox app can not only tell you where the closest iconic red kiosk is located, but also the closest that has the DVD or Blu-ray that you are looking for. Yelp associates virtually every business with its specific latitude and longitude and lists it the closest in proximity to the mobile device. Here you can essentially search for any type of service offered and it would return options to the user. Whether using a directional or retail app, the app is taking advantage of the location services functionality on the device itself to essentially locate itself. With so much data being transferred over the internet and stored on hosted databases, concerns arise over data security and privacy. Location-based services provide, collect, and store information specific to individual movement patterns, activities at specific locations, current and past locations, and even locations of friends and family. This highly permeable location data reveals a lot about how people live their lives and can be valuable to organizations wishing to provide services that consumers desire or, on the flip side, be abused, either inadvertently or purposefully, in ways that can cause damage to people's lives, used to commit crimes, or put national security at risk. Providers of location-based services must be able to address these concerns. The basic components of information security are often summarized as confidentiality, integrity, availability, authenticity, and non-repudiation, and are but a few ways information security professionals attempt to address concerns over data ownership, privacy, and integrity. Ownership retention can be addressed through intellectual property rights, ensuring the integrity of data owner identification values, logical separation of data between owners, and owner control of when and how data is removed from the host system. Privacy can be addressed through ensuring that data owners have the ability to configure their own security. This can be done through customizable user roles so that users within an organization can only access data that they are authorized to access. Additionally, authenticated user login systems help to ensure that only authenticated users are allowed to access individual or organizational data. Part of the login process often uses encrypted communication that leverages HTTPS technology for secure transactions over the internet and private key infrastructure, or PKI, that uses the concept of a trusted agent to maintain user account information and manage login keys. Control over data can be addressed by configuring the environment of the data storage and management system. Some data may be too sensitive to be stored in a shared data storage environment. Some organizations may not feel comfortable storing data such as police records, military, national security, and health records online. In these cases, sensitive data can be stored on a local infrastructure and only accessed temporarily when using shared software services. This option, however, requires more infrastructure to be maintained and managed by the host organization. This slide reveals questions that are important both for the user and proprietor to consider when interacting with data over mobile devices and applications. We hope that you have enjoyed our presentation and found it informative. Have a good day.